Okay, good. So I think the recording on already. Is it okay now? Okay, good. Okay, so I think we can start now. Okay, so last week we already learned about backtracking with coloring problem example, right? Okay, so in this week we will continue with another example for the backtracking algorithm. Okay, so this is about the eight queens problem. Okay, so I think so yeah, this is the chess, right? I think if you place the chess, then you know how the queen going, right? So the chessboard we have the 8 row and eight columns. Okay, then yeah, for the I mean, if you know to play the chess, then you know how the queen going, right? The queen can go within the rows, anyone within the rows, and any rows within the row, within the column, and within any position in the diagonal. Okay. So if any, just within the row or within the column or within the diagonal, right? Diagonal, right? The queen can attack this chess. Okay. So therefore, right? So in this problem, the thing is whether we can place 8 queens on the board so that no queen can attack any other queens in a move. It means that, for example, this one is a one setting, okay, one solution. So this one you can see, right? No queen can attack the other queens, okay. And if there's the solution, because the queen can attack on the position in the same row and the same column or the same diagonal, right? So normally one column, only one column and one row will be one queens, right? Okay, so that's the the problem is whether we can find the solution for this, so that we can place 8 queens on the 8 position in the chessboard, so that no queen can attack the others. Okay, so for that, right? So if we do the sorting search, it means that we search. So we try all the possible places and we try the sorting search. So we have the 64 positions and we place the 8 queen, right? So it will be the C of the 64 8, right? Or we have about 4 billion ways. So it's a huge amount of the ways that we need to search, okay, right? But if we limit it, that one row, because one row contains exactly the one queens, right? So we still need like the factorize of 8, or there are 40,000 of the configure, of the combinations. We need to search, okay? So it's still not the optimized solution, okay? So whether we can have the better algorithm, okay? So that's it, the backtracking can work in this scenario, okay? So how the backtracking can work, okay? So, okay, so that's the idea. So we just go with a simple one, 4 times 4. Then we need to place 4 queens. Okay, so just for the illustration. So we just, because you remember for the backtracking, right? Every time we don't have enough information, so we just try one. One choice. If not successful, then we try another one. Okay. So this one also the same, right? Because we know that one column only one queens, right? So we start with the first column first. So we start, okay, by playing a queen on the first column, right? Then which one we start? Maybe we just start with the first position. Yeah? We just play a queen here, okay? Then, okay, for example, we play a queen here, right? Then we start with the second, right? We place a queen in the second column, right? Because we know that it's we cannot place another queen in this column, right? So we need to place another queen on this column. Okay, so we just place a queen on the second column. Okay, then we move until we can place this. Okay, so for example, whether you can play this one, place the queen here, cannot, right? Because the first queen will attack the same row. Here also cannot, right? Because the same diagonal. Okay, so the first queen will attack. Here can, right? So you can place that. You can place the second queen here, and subsequently, right? You will place a queen on the third row, third column, right? For example, here cannot, right? Here also cannot. Here also cannot. Here also cannot, right? Okay. So assuming that, okay, if we cannot place, for example, the third column, right, then we do the backtrack. Backtrack is mean that we back to the second queens. It means that this one cannot place here, because if you place the queen here, you cannot place the third queen in this column, right? Then we go to another choice. So what the another choice? So this one, right? So we play the second queen here. So that's the idea, okay? So right. So that's the idea. So we play the second queen here. Then we try the third queen. We play on this row again, see whether or not. If you can place on the first row, for example, for this one, okay. Yeah. You can play here or not. If the first queen here, the second queen here, can play here or not? Cannot, right? Because they attacked by the first one. Here, can, right? Yeah, so you just play here. Okay, the third. And you continue to the last one, right? The last queen. Then you can play here or not? Cannot. Play here? Cannot. Play here? Cannot. Place here? Also cannot, right? Because it will attack by this one. So it means that the fourth queen you cannot place if you play the third here. Therefore, you delete the third here. You move to another one. Okay. So that's the idea of the backtracking. Backtracking means that for one particular thing, you play a queen in any position, and then you check whether you can place it in the next one or not. If not, then you backtrack in the previous one, then you try another one, something like that. Okay. So if we can place the queen in the last position, then we can finish that. It can be safer. Then we said that, okay, the puzzle already failed because we can place the final one, the final queen in the final column. So that's the idea for the, that's the one solution using the backtracking. Okay, so I just erase here first, and I make one illustration for you to see the way that the backtracking works, right? So okay, you look at the this one. Okay, you will see at first, right? We have no information, so we place the first queen. So we play it in this one. Okay. Then the next one, of course, the second queen in the second column, right? So this column, right? So you cannot play here, right? Because this one will be attacked by the first. Here also cannot, right? Because the same diagonal. Here can, right? So you play the second here. Okay. Then you will try the third one. Again, here cannot, here cannot, here also cannot, right? Here also cannot, right? Because you will attacked by the second one. It means that if you place the queen in this position, okay, you cannot play the third queen. So therefore, you need to backtrack to the second queen, and you play the second queen. You delete the second queen, okay. Then you place it in another position, okay. Then now, if the second queen here, then the third queen, first one cannot, right? Second one can. So we place the third one in the second one. Therefore, the fourth one in the fourth column. So we try. Here cannot, right? Here also cannot. Here also cannot. Here also cannot because we attacked by this queen. Okay. This means that we cannot place the fourth queen. It means that then we backtrack to the third queen. it means that the third queen cannot play here, right? So whether the third queen, how about the other choice? Here also cannot, here also cannot. It means that the third queen cannot place, right? Cannot place any position in the third column. Then we backtrack to the, so the third queen cannot, so we remove the third queen. We backtrack to the second queen. Now whether we can have any choice for the second queen. This is the last already, right? We will, this one cannot, and this one previously we said also cannot. Then we play here, place here also cannot. Then we delete it. We backtrack to the first queen. Then we delete it. We choose the next one, right? Because this one cannot, right? We just said that if this one, then we cannot place the three subsequent queens. So this one cannot. Then we choose to the next choice, so place here. Then again place here, right? Then we choose for the second queen. Here cannot, here cannot, here cannot, right? So the second queen here we choose here. Then for the third one we can place here, right? But if the third one here, the fourth one, this one cannot, this one also cannot, right? This one can, right? Because they're not attacked by the other. This one can, and then because this is the final queen, then we bring the result. Okay, this is the one solution, right? So there's one solution. One queen cannot attack the other queens. So there's a solution. Okay. So how we know that the queen can attack the others, right? Then we just run the one program to check, right? Check whether any queen in the same rows, same column. When we place the queen here, right? We just check, okay, any queen in the same row, same column, or same diagonal, right? Then if no queen there, then we can check, okay. Yeah, this problem may come out in the assignment 6. For the assignment 6, I will announce later. Okay, so at the end of this lecture, I will announce there's some announcements. Okay, about the assignment 6, 7, 8, 8, and then also the lab test and the quiz. Okay, so yeah, so you understand, right? So to check it, very simple. When you play a queen, you check whether anyone in the same row, same column, and same diagonal or not. If not, then it's safe to place. Okay. So yeah, this is a few solution for the this problem. It means that we can have a few solutions like that. Okay. So we just start with the first column. Then we try to place until we can place in the last column that is successful. Then we stop, or we can continue to search another successful one. Okay. But that's the idea for backtracking. So every step you place a queen to check. You check whether it's safe position or not. You place this, and then you call the recursive function to place the next one. If the next one returns yes, it means that you can safely place on the subsequent one. It means that this current position is also the correct one. They're okay. Yeah, right. So actually for this one, right, we have 8 time error. You have 92 solutions for this one. Okay. So that's the one illustration how it works. For example, you place the third queen here, cannot, then you play the third queen here, the third queen here. It also cannot, then you move to the second one. Okay. You see, you move to the second one, and you try the third one. Third one, you can see it move, right? Yeah, it move here. Also cannot, then you try the next second. Yeah. So that's how the backtracking work. Okay. So this is the pseudocode for the 8 queens problem algorithm. Okay. So you see, right? We have the board. It's just a board. It's just a 2D array. It just keep the position of the queen, right? So board is just an NN. So the board, if the board ij then the value will be 0 or 1. 1 means that there's the queen there. 0 means that there's no queen. It's just simply like that. So we just keep a 2D array, right? With the dimension is n times n. Okay. And for the position I and j, row I and column j, right? If there's no queen, then it's 0. If there's a queen, it's just 1. It's just a 0 or 1. Okay. Queen or not. Okay. So we keep a board. Okay. Then we have the stopping, right? So the stopping means that for every time we call the recursive function with the column, mean that the column that we are trying to place a queen. Okay. So if we reach to the last column, it means that we already placed the last queen. Then we just return true, right? We can place the last one, means that we can find the solution. Because when we are playing the last column, we assume that on the previous column already places, right? So when you can place the queen in the last column safely, it means that you can find the solution, then you can stop. So that's why you return true. Okay. If not, it means that we are placing, a queen in the middle column, right, or the first column, right? So how we do? When we place the queen here, right, there n position, right? In this column, right? When we are trying to place this queen, we have n position to place, right? Here, 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 right? So we just do the for loop. Okay. So the for loop will be run. So it just we try, right? Place here, can or not, 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 right? So to check whether here can or not, we just check, right, whether it's safe or not, right? So like I mentioned, how to check whether a queen is safe or not, right? In a particular, for example, 3 times 3. How you want to know that, okay, this one is a safe or not, right? For example, place here, safe or not. You just check on the row here, on the column here, and on the diagonal here, any other queen or not, right? If there's no queen, it means that's safe to place, right? Because the board, you have the board information, right? So you have on the information 0 or 1, 0 or 1, right? So you can check whether any one in the, for example, checking here, you see this row, this column, this row, or this diagonal, any place that have the queen or not. If not, then it's safe to place. So just write very simple function to check, right? Safe or not. Okay. Then if it's safe, for example, this one is safe position, then you place a queen here. Okay. Then you just call the recursive function to the next column. It means that after you place a queen here, then you try whether you can place a queen in the next one or not. So you just call the recursive function. Okay. So if you can place the queen in the next position, it means that it's okay to place a queen here, right? Then you just return true. Right? Okay. But otherwise, if you try on the position here, on the position here, so it means that on the for loop, right? You have the for loop. So you try on the for loop on the position here. There's nothing return true. It means that you cannot play any queen in this column, right? Because you are looking in this column. You try on the position, it on return false. This means that you cannot play any queen in this column. Then you just return false. It means that, okay, return false. To say that, okay, previous one also, if you place the queen here, you cannot play the queen in this column. Then you backtrack, right? You try another choice for the previous one. You try this queen here, for example. Okay, so that's a very simple one. Okay, so you just do the backtrack on the column. You start with the first column, then it call the second column, then second column will call the third column. Okay, so whenever one column return true, it will return true to the previous column. It said that, okay, you can place here because you can place the next one. It means that it's safe you play here. Okay, Otherwise, if the previous, the next column say that, okay, I cannot place any queen in the next column, then it will return false. It will return the signal to the previous column. It said that, okay, you cannot play the queen here. You try another one. Okay? Try another position. Okay? So that's it. And this one, you just check. If you can place, then you return true. If not, it means that you delete the queen in that position. You try another one for the for loop. Right? The for loop, you try the different position. Let me erase it. Okay. Yeah, for example, the for loop, right? It try here. Sorry. And yeah, it try here. Cannot, right? So you delete it. Okay. Delete it. Try here. Also cannot. Delete it. Try here. Try here. Can, because it's safe, right? Then you try the third column. For example, in the third column, you cannot place this. Then you just delete it, right? Then you try the next one. So that's it. Okay. They try until the I equal n. It means that you reach the last one. Then if also cannot, right? Then you just return false here. Okay. So that's it, the A queens problem. So then you just run the function with the n queen. Maybe because we start with the first position, right? So they are board. Okay. So you just run the n queen board with the column 1. They will automatically run. And if they can find a solution, it will return true. And the solution will be stored in the board information. Right? So it shows you that which position that you can place. Okay. So it will start in the board position. So the check position, yeah, of course, it will be provided, but actually you can check, right? You just check the row, the same column. So that is 2D array, right? Actually, you can simply write the function to check, right? Just check the row, the column, the diagonal, anything that will be 1, they return false, right? 3 times 3, yeah. 3 times 3, 3 times 3, 3 times 3. Actually, we have the solution, right? Let me see. 3 times 3 we have or not? 3 times 3 cannot. 3 times 3 cannot, right? Yeah, 3 times 3 cannot. Yeah, 3 times 3 cannot. Yeah. But here the base case to us is it's just that if we reach the column n, right, we stop. Okay. If the column greater or equal than n, it means that we can place the last column already, right? The last column, it means that the last queen. If you can place the last queen because you assume that on the previous one already placed, right? And if you can place the last queen, it means safely. It means that you can find the solution, right? Because on the previous column you already placed it. Right? That's why you return true, right? So this algorithm to see if the problem has the solution. Actually, you can find the solution, right? You can bring down the solution because the solution will start in the board. Okay. You can find. You can check whether there is a solution and what is the solution because the solution will start in the board. Every time you can see, you play the board, you just mark it like 1 or 0, right? You can delete the queen from the board. If there are 1, then you delete it, make it 0. Okay. Yes, you start from 0. It depends on how you define the board. If you define from okay, it's just about 0 or 1, right? You can start from the first column. If you think that the first column is it depends. If you think the first column is 0 to n minus, if you define the board is n, right? Then yeah, it starts from 0. Yeah, but it means that the first column, but the index is 0. Yeah, correct. Index is 0. Yeah. Okay. Column cannot be greater than n. because this is the redefined, right? I mean, like for example, I ask you bring down the solution for the board 5 times 5. So 5 is the input. So it means that you need to place 5 queens in the board 5 times 5. Okay. Yeah, can bring down the solution. Just bring down the 1 and 0. What? 1 and 0 is just the position, right? 1 means that the queen. 0 is no queen. Then after you see the board, I mean the value of the board, you can draw this I mean the chessboard. For the column equal n. Okay, yeah, you are true. That for the column, because we start with 0, right? So it means that the last one will be n minus 1, right? It means that we already placed n minus 1. So that's why when the column rate of equal n, it means that it's outside. Yeah, sorry. So it means that the column already outside. It means that we already safely placed on the queen before. Okay, so that's why we don't check here, because this is actually the outside, and column equal n, it means the outside because we I mean we start the index from 0 to n minus 1. N minus 1 is the last chest, right? The last queen. Then it increase to n. It means that we safely replace all the queen. So they are the outside the table. So that's why we stop. Okay. We don't need to check here. You can see, right? Here we don't check whether safe or not because it is actually outside the table already, right? If we start the index from 0 to n minus 1, right? So it means that we safely place on the previous queen. Okay. Then they'll go to outside the board and it stops. Okay. So that's that. So any more questions about this? Okay, so if no more question, then we continue with some announcement. Okay, why cannot? Oh yeah, it's just playing. Okay. Just some animation. Okay, so some announcement. Okay, so firstly, the assignment 6 will be released today. Okay, actually I plan to release yesterday, but there's some technical problem because for the Hacker Earth, right? They have the limitation of the invitation, and I think our school reached the limitation. So I'm trying to solve this problem. So if I can solve this problem today, I will release today. If not, then I will release sometime early next week. But the deadline is still 2 weeks for you to complete it. So no worry. Okay, still 2 weeks from the day I release. So assignment 6 will be about the depth first search and the breadth first search. Okay. So they know about the backtracking. Backtracking will be assignment 7. Okay. So assignment 6 will be released today. If I can solve the technical problem for the Hacker Earth, if not, then release sometime early next week. Yeah. But the deadline is still 2 weeks. Okay. And remember the deadline for the assignment 5 will be next Friday, right? Okay. The lab I will release today or tomorrow also. Okay, for the lab 7. Then okay, another good news for you guys. Okay, I understand that you will be busy at the end of the semester. Yeah, for the assignment 6, we still have the MCQ question. I mean, it's just a simple one, right? Yeah, this code we don't have the permutation. Okay, permutation is just backtracking. I mean, it's just one problem like the chess or the coloring, right? Okay. So for the assignment 7 and 8, I understand that you are busy with the end of the semester because you have so many courses, right? So I decide that I will combine the assignment 7 and 8 into one. Okay, so just one more assignment after assignment 6. So 7 and 8 will be combined into one assignment. Okay, so that you have more time to prepare for the final exam of the other courses. Okay, and although for the final test, the lab test and the final quiz. Okay, no, not about 6 questions. Okay, I not combine like that. Okay, so yeah, I maybe about 3 or 4 questions. Okay, just maybe one more question, then no more assignment. But anyway, it will combine. And the deadline, I will also extend it like 2-3 weeks for you, for example. Okay. Okay, then it's about the assignment. Okay, for the lab test, I will release before the the lab, and assignment. The assignment we also based on the lab question. So okay, but lab test, we have the lab test and the final quiz, right? The lab test, right, will focus only on the part 2. Okay, so no worry, don't forget about the part 1. So the lab test 2 will only focus on the part 2. Okay. So yeah, lab test 2. I understand that. Okay, so most of the question will be similar to the assignments. Okay, I mean the difficulties, but I will keep one challenging question. Okay, that means that if there are 3 questions, then 2 will be easy like the assignment. So I just keep one challenging question, because I mean, if I keep everything easy, then everything get an A, right? Then how the school will complain anyway. So I keep one challenging question. Okay. So I mean, yeah. So anyway, the information, I mean the question in the lab test, mostly also, I mean, based on the assignment in the lab. Okay. So I don't try to challenge you so much. Okay. Just one challenging question for the good student. Okay. But for the final quiz, because the final quiz is the quiz for the whole test, so it will cover both the part 1 and part 2. Okay. So because Dr. Locke will send me some question about the part 1, so I need to add it into the final quiz. So it will be combined part 1 and part 2. Okay. It's just for the final quiz theory. It's just about our MCQ question. Okay. This one I cannot control. Sorry, the question from Dr. Locke I cannot control. So whatever he said to me, that I need to incorporate into the final quiz. Yeah, MCQ question. It's not about the programming, coding or something. Okay. So I only in charge for the part 2. So the part 2 question will be similar to the question in the assignment. Okay. Yeah, the final quiz only the MCQ. I think it's only about the MCQ question. Okay. So the final quiz will be similar to the one that you did in the assignment. Okay. For the lab test, it will be similar like assignment. It's just one challenging question. You need to think a little bit. Okay. I mean, if you can, I mean, think carefully. I mean, the lab test, I don't ask you to write a very long one. I mean, if you can think a little bit and find a solution, actually you can just cut it in a few lines. But need you to think about that. Okay. Yeah, Dr. Locke will be in charge of the analysis of the algorithm question. Yeah. I mean, whatever you learn in the part 1. Okay. So Dr. Locke will give you some question in the final weeks. For my part, right? So whatever you see in the assignment, I mean in the MCQ, right? You will see similarly in the final test. Okay, no challenging things. I think it's very basic one. Yeah. If you study carefully and you do the assignment 6, 7, 8, then you will surely do the final weeks for the part 2. Okay. For part 1, I have no idea. Maybe you ask Dr. Locke. Okay. So yeah, for anything about the part 1, I have no idea about that, even though I don't know about the question. But I heard that, okay, and very similar to what you did in the assignment. Okay. For the quiz question. Be more about the, yeah. So for my part, for the part 2, right? it will be also very similar with assignment. Okay, the question in assignment. For the lab test, too, also the same. Yes, the question will be similar to the assignment. Okay. So yeah, I think that's it on the information I want to tell you today. Okay. So any question? For assignment 6, I will try to solve a technical problem for the hacker earth because our school reached the limitation of the invitation. So that's why I cannot invite all of you. Now we only left about 500 invitations. So we need to buy some more license to increase the invitation. So assignment 6 also the same. Five MCQ question and 3 programming question. But assignment 6 I actually just about, if you think you think a little bit, right? You just need to write a few lines. For sure, just a few lines based on the lab. Then you just modify, add a few lines more. Then you can solve this problem. Yeah. So yeah, but you need to think a little bit. I will release soon as you can see how. Yeah, not challenging, not much challenging. So I keep the challenging question in the lab test. One challenging question in the lab test. Yes, the lab test and the final quiz will be done on the same day. I think it will be combined also. It means that it's just like the assignments, right? You have some question, MCQ question before, and then some programming. Okay, it's just like the assignment. So the final quiz will be the MCQ question, and the lab test will be the programming question. Okay. So I think it will be combined like that. Okay, any more question? So yeah, if you have any question, you can ask me. Otherwise, yeah, I think we can stop the lecture today. Okay. So yeah, any question, just ask me. Okay. See you next week. Let me stop the recording. Okay, you too. Have a good weekend.